Can you guys hear me? Please say hi if you can hear me. So we are 13. Please share the group, share the link, share the link, share the link to your departmental platform, faculty platform, and the rest. We are just 13. I'll start very, very soon. Let's wait for others. So it's just a 30-minute video. I just discovered something day before yesterday concerning rigid pendulum experiment 4 in your physics manual. So I'm going to be sharing you guys what I discovered, and please, if you have not watched my former video concerning the introduction to physics 117, this video might be a little bit trickish for you, because you need to understand interpretation of equations, you need to understand the different cases of equation, you need to understand how you need to transform an equation to y is equal to ms plus or minus c. So you need to understand why a graph is meant, or a gradient or a slope is meant to pass through the origin or the intercept. You need to understand all those things before you can understand this thing we'll be doing here. So once is 7:07, I'm starting. So please share, subscribe, and stay active. Please share it on your status, share it on your departmental platform, share it with your colleagues. Now, if you miss the video, just know it to be here. Yeah, it will be here waiting for you guys if you miss the video. So, but it will be easier and better that we are doing it here and you're asking questions. For those that have missed our previous classes, before we start, we have different cases of I believe you can all see. If you can see, say yes. Good morning, Joshua. Okay, let's continue. So, cases of different graph plotting. So recall that in our previous video, for those joining us for the first time, we have case 1. Remember, is with y is equal to mx plus or minus c. This is the general graph equation. So for case 1, we have something like, y is equal to mx plus c. Now when you see this kind of case, you know that your graph is automatically passing through the y-intercept. This will be your m, which is the slope. This is the origin, 0.0. So this falls under this. Now for case 2, we have something like this is y is equal to mx, where if your y is equal to ms, that means there is no intercept. Automatically your c is equal to what? 0. Are you guys hearing me? For 3, we have we have the y, and this is the x. So this will pass through the negative what? This will pass through the negative intercept. So we have something like y is equal to m x minus c, because of the intercept is in what? The negative y, negative intercept. Let me number our page so that I'll not get confused. Page 2. We have something like case 4. We have so in this case we have something like y is equal to c, where my m is equal to 0. Note, you'll be asked in exam, so all these cases you need to know them. Your m is equal to 0, automatically your y will be equal to c, meaning that there is no what? No slope gradient. So that's for this other guy. Now let's look at what we came here to do today. Now we have this. Yes, in your general manual you are asked to do an experiment. You're asked to do this experiment 4, rigid pendulum. Determine the main m. Now once you are given an experiment to do, the first thing you should read is this: determine the acceleration of free fall using rigid pendulum. So now what are they asking you? They're asking you to find your g, and we all know that the constant for g is what? 9.8 to 10.0 meter per second square. This is your constant. But since there's error when plotting your graph or when doing your experiment, you're expecting to have something like 9.0 to, let me say, 10.5, because you are doing your practical, all of them in meter per second square. You're doing your practical, so anything between this range and this range, you're on the safe side. Anything you're having and is like 24 meter per second square, you're not in Jupiter, you're not in Mars, so this is not even related to what? The constant 9.8 to 10.0 meter per second square. Hope you understand. Please, if you understand, say hello. Okay, Bright is here. Okay, Idiom is here. Okay. So let's continue. Now, looking at this, now I told you in our previous video, introduction to 117 and practical physics, that in every equation, the first thing after looking at the topic, you look at the m. The next thing you should find or you should look for is your t is equal to 2 pi, or let me don't call the equation. The next thing you should look at is the equation of that experiment. The next thing you should look for is the equation of the experiment. So let me assume that we have the equation here, which we are going to be doing now. We have the equation t. Let me write it down so that we'll open it. Page 3. T is equal to 2 pi square root of h square plus k square, bracket open and close, all over GH. The square root is affecting all of them here, all over GH. So you are given this and you are asked to plot a graph. You are asked to plot a graph of HT square against H square, or H square against HT square. Now, remember we did this in class. We did this in our class. For Town Campus, we didn't do this. But for PEMSA, we did this in our class. But now, that hint is, this is where I want to give you the hint. Now, which one is preferable to use? Some people might use this, some people might use this. So with this equation here, I'll tell you which one is preferable for you to use so that you plot your graph and you get a good graph without stressing. Now I'll try making HT square subject of formula, and I'll make H square subject of formula, and we'll see the equation for both graph. And remember, remember you have a graph of, plot a graph of another one. This experiment, rigid pendulum, is always two graph to plot. We have another one, T against H. This graph will look like this. To be a parabola graph, where here is T and here is H. I'm going to do all this in our YouTube channel, which I'll be posting tomorrow. Yes, I'll do all this again. Now, what's the next thing we do here? Let's use this equation to make the subject of formula and make this subject of formula, and check which one is preferable when plotting our graph, so that we'll not have issue. Two of them will have different kind of case. These two of them will have different kind of case. This might be this, and this might be this. We don't know yet. So let's, after we equate this guy to this guy, and equate this guy to this guy, we will know which one that will be having this, or the one that will be having this. So good morning, welcome. So if you are still with me, say hi. Okay, let's dive in. Let's dive in. Page 4. Page 4. Now, what was our equation? T is equal to 2 pi square root of HT plus K square all over GH. Now, I believe you remember change of subject formula, which I've done in other video. Now, what if they tell you to find HT square against H? That means they want you to make HT square subject of formula. So this will stand alone, just like this guy here. So let's dive in. The first thing you do, you square both sides. So that will remove the square root. So if I square both sides, I will have something like HT is equal to, T square is equal to 4 pi square, bracket open. This will cancel this. So therefore I have H square plus K square all over GH, bracket close. This is step 1, equation 1. Let's call this equation 1, and let's call this equation 2. Now the next one is, we open bracket. T square is equal to 4 pi square H square plus 4 pi square K square all over GH. Now remember, make this subject formula against h square. Now what we are trying to do is to make this equation look like y is equal to mx plus c. This is what we are trying to do here. So therefore, t square is equal to 4 pi square h square plus 4 pi square k square all over gh. So let me call this to equation 3. Equation 3. So from here, I'll have something like cross multiply, and I'll have ht square is equal to 4 pi square h square plus 4 pi square k square. All over. Okay, you're not dividing by anything. This is equation 4. So to divide it, we'll make ht square subject of formula. So we divide it through by g. So g will cancel g. Therefore, I'll be having something like page 5. Let's number our page. Therefore, I'll be having something like from here. I'll be having something like h t square is equal to 4 pi square h square all over g plus 4 pi square k square all over g. Now automatically this equation is looking like y is equal to mx plus c. That means this graph must, is not me, must pass through the positive axis of the vertical line. This is how the nature of this graph will look like. This one we are plotting a graph of ht square against h. Now where my y is equal to ht square, my m is equal to 4 pi square all over g. Very important. This is how you get the g from the graph. My x is equal to h square, and my c is equal to 4 pi square k square all over g. Now if you don't have this g, you can't find the radius of what? Gyration, which is k, not k square, k. So you make k subject of formula, and you pick the c from your intercept, wherever you have here, whatever you have here when plotting your graph. Then you make k subject of formula, and you have your radius of gyration, which you ask one of the questions in your manual. So this is how to make this guy work. Now remember, I told you guys in class that in our previous video that let's bring out this guy. Remember, the m is to find the what, so there'll be marking based on the m. The m is to find g, very important. So my g will now be equal to what? 4 pi square all over m. The m is aka slope. You make g a subject of formula. Once you make g a subject of formula, this is what you are getting. This is what you are getting. Do you understand? Say yes, brush G. I'm not saying yes, brush G. Okay. Okay, let's continue. So now from here, now I said something, I gave you guys a scoop, which I'm going to say it here so that others will benefit. I give you guys a scope. That scope is Let's assume you don't know the slope for now. You don't know the slope, and you just want to manipulate how your slope or where your slope will land before you start plotting your graph. You know that, okay, I must have this range of slope from here to here. Now, this is what you did. Now, let me assume that my slope, remember, I'm assuming, I've not plotted any graph yet. I'm assuming that my slope is equal to what? 0.038, or my slope is equal to 0.04. So bring out your calculator. Bring out your calculator using this guy here. Multiply 4 pi square divided by, let's first and say 0.038. Type the answer in the live section. Hurry up. Bring out your calculator. Let's check if our G will fall between the constant G. I believe everybody is doing that now. What's your answer? I'm waiting for you guys. Yeah, that's correct. Joshua, that's correct. Who else? Okay, Bright, I should recap on the process. Are you just joining us? Don't worry, the video will be here for you to go again and watch. But for now, multiply 4 pi square divided by 0.038. Let's see what you'll be having. Okay, David, get your. Okay. Okay. Okay, Dara Solo. Okay. Now, I don't know if you are understanding what we are trying to do. Now, the next thing, everybody multiply this 4 pi square divided by slope. Now, let's assume our slope fall under 0.041. Everybody, do this one. Do this one now. We are all done this one. We are having, what we are having here is 10,038.9. That's what some people are having. This is very correct. Whereby if you divide it by 100, you have 10.3. It's falling under G. It's falling, it's trying to make sense now. Meter per second square. Remember, this one is in centimeter per second square. Now, this other one, what are we having? This other one, what are we having? Okay, 98. I need to say it's 98. 986.96. Any other person? Okay, same with same with David. Okay, so if we divide this by 100, what are we having? 9.86. Okay, Gideon, that's correct. Gideon, that's correct. Meter per second square. Now, have you guys seen the manipulation I did here? So now, if you are plotting your graph, make sure your slope is falling between this and this. Just know that you're having this as your meter per second. Make sure your slope is falling between 0.03839, 34, 36, 37, 38, 39, 0.04, 0.041, 0.042. Now you can see this, right? See the manipulation there. So now you already have in mind that anything I'm doing, my slope must be in this range. That's the secret I want to tell you guys today before I start doing video, so that you don't ask plenty questions. Now, that is for what? Remember, that's for h t square against h square. Ht square against h square. Now, let's plot a graph of, let's plot a graph of h square against ht square. Let's plot a graph of h square against ht square. Should we start? If you want us to start, say active. Okay, we are active then. So let's plot a graph of h squared against ht squared. Now I'll show you the difference between the two. After plotting the graph, I'll show you the difference between these two and which one is preferable. So let's dive in. I believe everybody is seeing. If you are seeing, give a thumbs up. Please don't forget to like, subscribe, and share. You can't get all this knowledge alone. It's not good. It's not healthy. Share it to your colleagues. Now, h square against ht square. We have plotted the graph of ht square against h square. Now it's h square against ht square. Which one is preferable and which one is easygoing? Now, given the equation, t is equal to 2 pi square root of h square plus k square all over gh. The square root is covering everything. Now let's call this equation 1 again. The first thing, we square both sides. Remember, we want to make this subject of formula. The first thing, we square both sides. So therefore, t square is equal to, if I square both sides, I'll be having this 4 pi square, bracket open, h square plus k square, bracket close, all over gh. So therefore, h t square is equal to Science Arena. I'll not answer your comments. ht square 4 pi square h square plus 4 pi square k square all over gh. Leave my pop 2 alone. So therefore, we cross multiply. GHT square is equal to 4 pi square. I'm coming down to solve this so that I want everybody to follow. H square plus 4 pi square k square. Now, what are we making subject of formula? We are making this subject of formula. So GHT square minus, we are carrying this guy over to here, minus 4 pi square k square is equal to 4 pi square h square. Now, there's a minus in this equation. There was no minus in the other equation. So therefore, let's move this guy to the right hand side. 4 pi square h square is equal to GHT square minus 4 pi square k square. So therefore, we divide through by what? 4 pi square. 4 pi square. So therefore, 4 pi square. 4 pi square. 4 pi square. This will cancel this. Now h alone, h square is equal to h t square g all over 4 pi square minus 4 pi here will cancel 4 pi here, so we have k square. And this is how this equation will be looking like. Sorry, I interchanged this guy. Let me return it back. So this is page 6, right? Page 6. So from here, let me rewrite the last equation. Page 7. We have h square is equal to GHT square minus 4 k square all over 4 pi square. You see that there's no 4 pi in this one. The equation is totally different from the last equation we did. The equation is totally different from this equation. This is a graph of ht square against h square, and this is the equation for h square against ht square. Now you see that they are different ballgame, they are entirely different from each other. If you are following, say brush J, I'm following, because it seems somebody is commenting again. Just type brush J, I'm following. So therefore, okay, that's good. So therefore, from here, we have this will be y, and this will be the nature of your intercept. This will be the nature of your graph, please, because it has a negative what? Intercept. So the difference between ht square against h square is that one, the other one by the equation is passing through the positive, but this one, h square against ht square, is passing through the what? Negative. Okay. Somebody is confused. Don't worry, I'll do a video on experiment 4, rigid body, completely, totally from the beginning. But if you are confused, I'll advise you to watch my previous video on introduction to 117. You understand so many of these things we are doing there, we have done it there. Please go back and watch those videos. Like, subscribe, and share. Now, let's go back to business. Now I can say my y is equal to h square, and my x is equal to what? ht square. My m is equal to g all over 4 pi square. Now you observe that the other one, the 4 pi square was up and the g was down. But this one, the g is up and the 4 pi square is down. Therefore, my c will be equal to what? K square. So how do you have your radius of the gyration here? You just square the intercept. Once you square the intercept, you have your answer as your radius of gyration. Simple. Remember, I'll tell you after doing the two, I'll tell you which one is preferable. Now, from here, what are we going to assume our slope will look like? Let's carry this equation down. Therefore, my g automatically will be what? My g will be equal to m, which is my slope, times 4 pi squared. Now, this one is different. After converting it, you see that our m will be multiplying by what? Our m will be, radius of gyration is k, not k squared. So we are moving this guy here. Please don't be confused. Therefore, my k will be equal to what? Square root of c. Simple. Do you understand now? Amaifiok Abia. Do you understand? So therefore, from here now, you see something like this. What are we going to assume that? What do we going to assume that our slope here will be? Can we guess? How are we going to assume that our slope here will be? Who can guess? Who can guess? I'm waiting. Who can guess? So after the class, I'll be doing giveaway for after this class I'll be doing giveaway for first 10 people to share that have shared this to their group, and five people subscribe to this channel. I'll be doing giveaway on that, on your data, 1,000 naira data. So let's go back to business. Who can guess our slope that we'll be using here, so that when you are plotting for this one, you know that, oh, if you are doing a graph of h square against ht square, it's going to be a graph passing through the negative intercept. And our range of slope will be so to so this. So who can guess? Once we guess this, we'll know that our g, remember, we are supposed to have our g from 9.0 to 10.5 due to error we experience when doing the practical. So who can guess this? Is someone guessing 0.03 minus 0. I mean your m. You're picking your m from the positive part. Change in h square against change in ht square. This is where you're picking is a positive, not negative. Someone says 0.24, someone says 0.25. The other one say minus 0. Anything minus is wrong. Joshua say 24 to 26.5. Oh, okay. God's will say 25. Okay. More guess. I'm going to pick the guessing from the comment section here. Now let's go back to business without wasting much time. G is equal to, someone says 0 no work. 0.0 no work. Remember, we are doing it in centimeter. 0 no work. All these things are already in centimeter. So let's pick Goswe on. Goswe say 25. Let's start with Goswe. 25. So we have, let me say 25. Remember, this is in centimeter. 25 centimeter times 4 pi square. What will be our answer? Everybody point your calculator. 25 times 4 pi square. Wow. 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 I'm seeing a very good answer. 986.96. 986.96. Is that what you're having? 986.96 centimeter meter per second square. This is very, so anything you are doing now, yeah, I need to have seen that. Anything you are doing, yeah, Joshua, I've seen that. Idiom, I've seen that. Anything you are doing, make sure your slope is falling under 25. Okay, somebody gave us a range here, 24 to 26.5. So someone should try this in 24. Someone should try this for 24. Someone should try this 24. Because it's a getting job. That's brilliant. That's very brilliant. That's very correct. Now, this is physics practical made easy. Very easy. This is physics practical made easy. So imagine thousands of students in that lab not knowing what their range is. But you know your range before you even enter there. Your range of slope. So who is doing 24? Who is doing 24? I know he's doing 26. Who is doing 20? Who is doing 26.5? 26.5. Someone should do 26.5. 24 is 947.7. 947.7 for 24. Blessing, that's correct. That's correct. And 80. Legendary, that's correct. Now, 24 can still go. Now, please, I'm begging you, don't do this in plotting your graph. Don't go and forge your slope. Make sure you show the working of how you got your slope. If your slope is 23, just clean it and do it. Make it look like 24. I'm not saying you should have 23 and go and be putting 24 because you know the range of your slope. Now, for 26, what are you having? 10.1026.43. Perfect. 1046.17. Blessing have 1046.22. Beautiful. Beautiful. This is amazing. Clap hand for yourself. Clap hand for yourself. Everybody clap hand for yourself. Clap hand for yourself. If you're not clapping for yourself, you're wrong. Clap hand for yourself. You deserve it. You deserve it. Clap hand for yourself. Everybody giving me answer and you're alive. Clap hand for yourself. Even though you don't understand, at least you have picked something. Okay, the last part before we call it a day. The last part before we call it a day. The last part before we call it a day. Don't worry, the video, you can go and watch it again. You can go and watch everything again. It will be here. Once I stop, or share it and you guys watch. Or you can share it to your friend. So this is the paper. Now, the last part. Which one are we going to use? Bro, you don't do two beautiful work. We have done two amazing work. We have done for experiments. We have done for experiment for rigid pendulum. We have done ht square against h or h square against ht square. Roger, which one now are we going to use? Which one can we use? That's the next question. Are you still active? If you're active, say Roger, right on. If you're active, say Roger, right on. Okay, I'll show right on. Let me write the two equations. After deducing it, for h t square against h, this is our equation. Ht square is equal to 4 pi square h square all over g plus 4 pi square k square all over g. Right? That is for this, square here. For h square against ht square, we have g ht square all over 4 pi square minus k square. Right? Now, which of these is preferable? Which of these is preferable? Who can guess? Who can guess? Someone should guess. If you are guessing, just put 1 or 2. If you are guessing, you can say 1 or you can say 2. Which of these is preferable? Okay. Fon say 1. Tiene say 1. Dara say 1. Tene say 1. Mwalele say 1. Wisdom say 1. Anete say 1. Joshua say 2. Solomon say 2. Abia say 1. Legendary say 1. Victor say 1. Ephraim said 1. So we have plenty 1 and few, just 2, 2. We have plenty 1 and just few 2. 2. Idiom say 2. More comments. 2. Cherry say 2. Okay, Blessing say 2. Okay, 2 are coming up now. Okay. Idorian say 1. Kelly say 2. Oh, Kelly say 2, yes. Okay, Precious is asking the question. Which of these is preferable to plot? A graph of ht square against h, or a graph of h square against ht square? Which is preferable, Precious? That was the question. David said 2. Now I'm going to tell you which is preferable and why. Which is what's preferable and why. Now let's dive in without wasting much time. Please, after the live video, I need chicken and turkey with fried rice. I want chivita by my side. Arena say 1. Precious say 1. Dara say 1. Let's dive in and let's... Roger is here to explain the reason and why you should pick. Now, check number 1. This is for number 1. And this is for number what? 2. This is for number 2. This for 1 and this for 2. Now let's start with the whole title. For 1, we have h t square against h square. Ht square against h square. Now, what's the unit for ht square against h square? Let's start with the unit. Remember, we did dimension, which I'll be posting a video soon on dimension. So therefore, we have cm s square divided by cm times cm. This is how I can break this for you. Now, this is the unit of this, and we are trying to find the dimensional analysis. You see why dimension is important. Now, h is in centimeter and is in square. So therefore, this will be cm times cm, which is cm all squared. The same thing applicable to this. Cm s square. You can say s times s. Somebody say right on, brush J. So therefore, this will cancel this, right? Please pay attention. You need to understand this. Pay attention. This will cancel this. So therefore, we'll be having x squared divided by cm. Now, therefore, if we are converting this to meter, we'll have what? S squared divided by meter. Now, in your life in Nigeria, in the whole YouTube channel you have been watching, have you seen any unit that is s squared against m or s squared against cm? Scientist Ayana is saying, yeah, it's 2. You have choose 1. You are not going back. You are not going back. Your 1, they on your 1 lane. Your 2, they on your 2 lane. Don't switch side. You are not doing switching of side here. If you are in 1, stay on your 1 lane. If you are in 2, stay on your 2 lane. Now, have you seen any? Now, I told you that I'll tell you secrets, and this is secrets. We are now a secret after explaining many things. Have you seen any units since you were born or since you started studying physics, SS1, SS2, SS3, JS1, all of them, have it as second square per meter? You have not, right? Please, I need a reply. Have you? Yes or no? No, you haven't. Yes, you have. If you have seen, please, I would like you to teach me that part of physics. Now, equation 2. For this here. 2. What didn't she say? We are certain. You are certain, no? You must be certain. This is physics. Anything that is physics must be certain before it's proven, before a law will come out for it. Now we have something like, for 2 we have h squared against ht squared. Now, cm times somebody said there's uncertainty principle. Yes, but that uncertainty principle is in another term, is in energy, not in units, is in energy, particles, and mass. So therefore we have cm times cm divided by cm s squared. Pay attention everyone. So therefore cm will cancel cm. Therefore we'll be having Cm all over s square. Now remember, all our slope was in centimeter. So if we convert this guy later, we'll be having meter per second square as our G. 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 So now I ask the question. I ask the question again. Equation 1 and equation 2. Which one are you plotting? I need reply. Everybody send your reply. Equation 1 and 2. Which one are you going to be plotting? Which one are you plotting? Everybody. So we are all plotting a graph of, we are all plotting a graph. You can all agree with me that we are plotting a graph of h square against ht square. Please, this should be the graph we are plotting. And thank me later. This should be the graph you are plotting. And thank me later. Put your hands together for brush G. Put your hands together for brush G. Put your hands together for brush G. Error in G. Okay, David is telling me, sir, please stop at error in G. I've forgotten that part a bit. Go to my YouTube channel, check on introduction to 117, part 2. Watch everything, you see it. Yeah, God bless me, amen. Thank you so much. So that is the essence of this morning class. That is the essence of this morning class. That's the essence of this morning class. Hey, Scientist Arena. Which one is God bless me with wife? You know my prayer point. You of all people know my prayer point. Stop it. Stop it, sir, please. That prayer is too dangerous. Amen. Legendary. Thank you. Amen. You're welcome, David. You're welcome, David. Make I come back first. Whoa. I can't wait. Precious, you're welcome. Now, after all my suffering, Joshua is still asking me for data. He's still asking me to give him data. We'll marry. We'll all marry in Jesus' name. Marriage is all our portion. Okay, you don't get from the beginning. Once this stop, you are going to go back and watch everything again. It's on YouTube. It's saved there. So once this stop, once I end this live video, it's saved on my listen. Anybody can access it. You can even download it in the night and watch it on yours. Yeah, you guys are expecting Jerry. Yeah, you guys are expecting a video on experiment 4. Rigid pendulum from beginning to the end. No. Legendary two graph. One is a graph of h square against ht square. The other one, you are asked to plot a graph of, if you are here from the beginning of the video, you're asked to plot a graph of h and a graph of t against h. That's the parabola graph. Please ask your question. I'm answering all questions now. Just 5 more minutes or 10 more minutes to ask question. Merry Christmas too. Merry Christmas. Please make sure everybody bring my gifts when you are coming back from the village. Merry Christmas in advance. You're welcome. You're welcome, Wisdom. You're welcome. You're welcome, Abia. You're welcome, Hope. You're welcome, Tini. You're welcome, Ephraim. Okay, from your table, I'm not seeing any negative value. There's no negative value, but your intercept is passing through the negative side. So you just need to number the scale that you gave in positive axis to the negative axis. So I've answered you, Tini. Okay, authentic trade is just joining now. So you're going to watch all the video. Trade, you're going to watch the video. Once we stop it, it will be on YouTube waiting for you. Yeah, number 6, I'm still telling you, there is no negative. You can't formulate your negative t and h. So you're just going to plot a graph of one side. Do you understand, Tini? Except you want to formulate it with your own brain. So from the table, what I'm seeing here, I'm not seeing any negative axis. Can't get a negative axis. Oh, Ezekiel, welcome. Thanks for joining. Okay, you don't say you don't understand. What do you not understand? Benjamin, what do you not understand? So just those that don't understand, you have not watched my practical experiment. You have not watched it for part 1 and part 2. So go and watch Introduction to 117 and you understand what we did here. Number 6. Okay, you don't understand number 6. They say plot another graph of t against h for both positive and negative value of h. That is for points of support on both sides of the center of gravity. This should give a pair of curves symmetrical about the t-axis, which show minimum of h equal to plus or minus k. 7. Deduce the value of radius of gyration k from the second graph. Now, I'm saying the same thing. that you can't get a negative value of h when you don't have a negative value on your table. So you are just to plot a positive value. Do you understand, Benjamin? Okay, Joshua understood. So we call it a day. Anticipate experiments. Anticipate experiments for video rigid pendulum soon. So I'm going to see you guys in our next video, and make sure you share this live once it stops to everybody around. Have a beautiful day. And no, I told you the graph will be parabola. Once I do it, you understand. So have a good day. See you guys in our next video. Ciao. Don't forget to like, subscribe, and share to your colleagues and your platform. Thank you.